Students, from this slab 2 of exercise 1C, now we're now going to do the last question, question number 12. Okay, so you can see question number 12 given here. Can two positive numbers or can two positive integers have 812 and 28 as the HCF and LCM respectively? That means what? I think this is a mistake because LCM is always bigger than the HCF. Okay, so here 28 should be the HCF and LCM should be the N12. Okay, even if it's correct. Okay, so okay, ignore these things like big one should be always LCM and small one should be always HCF. Okay, so otherwise the question is very clearly asking you, can these two given numbers be the HCF and LCM of any two positive integers? Note one thing, in this particular question we do not know what are the actual positive integers, the two positive numbers we don't know, but they've given us two values or two figures or two numbers which they are asking us, can these two numbers be the HCF and LCM of two such positive numbers, of any two positive numbers? So it's a very peculiar question because in one hand you don't know which are the two given positive numbers, like say in question number 4 you know 336 and 54 and then you have to find HCF and LCM. You know 225 and 867 in question number 4, you have to find HCF and LCM. In this 12 we don't know the two positive integers or two positive numbers, but they're asking you, can these numbers be the HCF and LCM, be the HCF and LCM? Okay, so to do this question we have to do something based on reasoning. Okay, what like one more thing I'll tell you, the same question number 12 has been done here in one of the examples. Okay, example 8 from your textbook. In example 8 also same question. So can two positive numbers have 15 and 786 as the HCF and LCM? Here it's good respectively, so it's okay. Here HCF is 15 and LCM 786, but is it possible? So see, here you'll find the solution mostly based on reasoning. Okay, so we'll do exactly same way here also. It's all based on logic and reasoning. Okay, clear? No formula, just logic. Okay, so let's start question number 12. So to solve this answer, we start with the definition of HCF and LCM. Okay, we start with the definition of HCF and LCM. Okay, so first we start with this. Let HCF be equal to, HCF should be small number, so say 28 and LCM be equal to 812. So let means is this purely assumption. Okay, we're not sure whether HCF is 20 and LCM is 812. We don't know, so it's just an assumption. Okay, let HCF be equal to 28 and LCM be 812. Okay, then here we write, we know that, what do we know? Then here we write the definition of HCF and LCM. We know that HCF is the, remember in all the previous videos while finding HCF I'm telling you that HCF is nothing but is the product of all the common prime factors with the least power, with the lowest power. So we know that HCF is the product of all the common, should be same, okay, common, of all the common prime factors with the least powers, and those common prime factors should have all least powers. Okay, the powers of those common factors should be taken the least. Okay, and you also know that LCM is what? LCM is the, I've been telling in all the sums previous videos, LCM is the product of all the prime factors. That means what? Here we don't look for common, we just need prime factors, all the prime factors, common, everything. LCM is the product of all the prime factors with the highest or greatest powers or exponents. Okay, so from these two definitions, look, HCF is a product of all the common prime factor with least power, and LCM is a product of all the prime factor with the highest power. So from these two definitions, we can say that what this means that for any two positive numbers, more precisely integers, positive integers, the HCF, because HCF contains all the common prime factor, this HCF must exactly divide the LCM always. That means what? For any two given positive integers or any two not given positive integers also, like in this question, but one thing is sure that HCF must completely divide the LCM. Means LCM is always divisible by the HCF. Means if HCF is the divisor and LCM is the dividend, then remainder should come 0. Okay, so let me show you some examples of few sums that we have done. So here's the example of question number 5 from this exercise 1. In question number 5, they're telling you find the HCF and LCM of the following pairs of integers. So here two integers given here, 26, 91, 21, 215, and this one. So here I've showed you how to find HCF and LCM. Okay, so I want to give example of these sums, okay, to explain question number 12. Like see, in question number 5.1, where we have found HCF and LCM of 2691 by doing prime factorization, HCF is the product of only the common prime factor with the least power, and LCM is the product of all the prime factor or prime factor with the highest power. So that means for this two given numbers 2691, HCF is 13 and LCM is 182. Suppose I put the same 13 and 182 in this sum. Can two positive integers have 182 and 13, or 13 and 182 as their HCF and LCM? Then that is very simple. If these two numbers are HCF and LCM of any two numbers, then based on our explanation just now, logic, that HCF must divide LCM. So here which is the HCF? Here HCF is 13. So HCF must divide the LCM completely, means remainder should come 0. Okay, if these two numbers are correct, okay, values are correct. Let's divide this. In this particular case, HCF is 13 and LCM is 182. So let's see whether remainder comes 0 or not. 13 ones are 13 and 5 and 2. So 13 fours are 52, remainder 0. C. That means here HCF divides LCM completely. See, 13 divides 182 completely. So that's why yes, 13 and 182 are HCF and LCM respectively of these two given numbers, or of these two numbers. Okay. Same here with this number 3. Look, in number 3, these are two positive integers given to you. In question number 5, okay, I'm just trying to explain you. So in question 5 also, see, for this two given positive integers, after doing prime factorization, we have found HCF 11 and LCM 6853. So if these two HCF and LCM are correct, then see, this by this HCF LCM should be completely divisible. Okay, this is true for all the numbers, for two positive numbers. Okay, so see, 11 6 are 66, 11 2s are 22, 3 and this 3, and 11 3s are, see here in this case also remainder 0 as well. HCF is dividing the LCM completely. Okay, clear? It must divide. Okay, that means what? If you don't get a 0 means what? That means those two given values are not proper values. Okay, are not the correct values. Okay, means they are not HCF LCM. Okay, of two positive numbers. So that means what? Now, in order to be sure, or in order to find out whether these two numbers are HCF or LCM of any two given of any two positive integers, we just now have to divide this LCM by this HCF and look for remainder value. Okay, if the remainder comes 0, that means HCF divides LCM completely. So in that case, yes, it's true. Okay, these values are HCF and LCM. But if the remainder don't come 0, it means that it becomes clear that these values are not the HCF and LCM values of two positive numbers. Okay, clear? Because from this discussion we know that this means that for any two positive integers, HCF it must it must divide the LCM completely. Okay, and that also always do not underline your copy or in your answer. Just I'm showing this, okay, to explain you. You can copy this all, but okay. So that means now, so now to check whether these two numbers are HCF LCM, now we divide. Okay, now dividing 812, that is our supposed LCM, by 28, which is our supposed HCF, we have, so let's divide 812 will divide by 28. Okay, so let's divide so 28 how many times? Let's see. 28 into 24 6 7 8. So look, if I do 28 three times, 84 back, so 28 twos are 56, so 28 twos are 56. 11 minus 6 5, 7 minus 5 2, and then this 2. Now 28 9 9 is 72, 9 to 18, 18 plus 7 25. So means 28 nines, 28 nines are, get 72, 9 to 18, and yeah, we get 252, and see the remainder has come 0. Look, so in this case the remainder has come 0. So we'll write here, since 28, that's here, divides 812, which is our LCM, exactly, because remainder 0, because remainder has come out to be equal to 0, remainder 0. So since 28 divides the 812 completely or exactly, therefore we can say what? Yes, so therefore we can say that yes, therefore yes, two positive integers, which are the integers we don't know, but they can have, therefore two positive integers can have 812 and 28 as their LCM and HCF respectively. So we have found that yes, two positive integers can have 812 and 28 as their LCM and HCF respectively. So please do the correction in your question also. Can two positive integers have 812 28 as their? So this HCF should be replaced by LCM and LCM should be replaced by HCF. So now the question is also correct and answer we have found. Okay, so answer is yes. Okay, so have you all understood? Okay, so this is the way of doing number 12. So with this we have finished exercise 1C, slab 1 and slab 2 all. Okay, so in the next class or next video we'll start with exercise 1E. Thank you so much.